Today we'll be looking at the first part of a 3-webinar series. So today is really focused on the planning and creation portion of a project. So we'll start by looking at the traditional sustainable drainage project approach. So kind of what that is in general, and then look at the XPDRAINAGE workflow. So that workflow obviously covers more than just planning and creation. So we'll look at, I guess, a little more itemized what exactly we'll touch on today in this kind of first part of our 3-webinar series, and then pretty quickly jump into, I guess, what a lot of people are most interested to see is real live project work. So before we do anything, I like to make sure that everyone's on the same page, make sure there's no confusion. What are we talking about when we discuss sustainable drainage practices? So that's a pretty large term. There are some other terms that might be used: low impact development, LID, green infrastructure, GI. There's a range, there's SUDS, WUS-SUDS, a range of different acronyms, descriptions of this greater idea of sustainable drainage. So I'm going to use probably the terms green infrastructure or low impact development today, talking about kind of that greater practice. Now, there's also the individual elements which make up this practice, be it rain gardens, swales, or just controls or practices. Those are going to be called stormwater controls, just to clear that up. So when I refer to a stormwater control, that's an individual element, as we can see on the images on the right, an individual, what I might call a green street, bioretention, or a swale or wetland. Okay? So what is the traditional sustainable drainage project? What does this look like? Well, for the vast majority of the U.S., when we have a green infrastructure project, we are designing usually towards one thing, and that's what we might call the first flush, or water quality volume, water quality event, those abbreviations I have on the screen. So what is that? That's a pretty significant assumption we're making. So we're saying that let's pretend that it's been summer, it's nice, it's been August, it hasn't been rain for a while, but then, okay, right into September we have a good downpour. So assuming that the impervious areas have been driven on, parked on, used, there's a lot of negative pollution, negative constituents which might exist on those surfaces. So the first time it rains, and we usually, as the industry goes, we're going to say about 1 inch of rain. That might change depending on where you're at. Maybe 1.2 inches of rain will be that first flush event. Okay, so picture 1.2 inches of rain falling on those parking lots, let's say. That volume, when it washes off the parking lot, is going to carry with it the vast majority of those negative constituents, those pollutants. So that might not always be the case, but that's a pretty good assumption, and that's what is really used to dictate our design. So what do we have to do? We have to get that volume, and we have to retain it. So that polluted runoff, we can't let go into our streams, tributaries, or other sensitive areas. Retain it, infiltrate it on our site, or treat it. But again, that might be kind of a minor event compared to what we might call the flooding events, the 2 through 100 year rainfall events. So with our green infrastructure in particular, we're going to retain and treat our water quality first flush event, but then also be able to bypass and attenuate these higher flooding events. Again, we're still the practice we've had for many years of not impacting our downstream neighbor with higher flows and perhaps increased volumes for any rainfall event up to the 100 year. We still have to follow that. So what would a project look like? This is some example from a project I outlined previously. So this is representative of, I would say, kind of a smaller project. So we're looking at 3.5 weeks of work, so about $12,500 of just this drainage design budget. So how does this project break down? As this project was bid, we have the following, right? We're going to have the initial proposal, preliminary plan, being 14%. I think that's about 2.5 days. So we have that being the first part of this project. Then we get into, really once we've won the project, we get into defining the runoff potential of the site, defining the inflow areas, okay, what kind of the runoff or wash-off might be. So again, those are both, let's just say, about 2.5 days, perhaps a little bit longer in time. As we would bill it, would be delineating our treatment train, our kind of initial first pass of how we need to clean up the water on that site, how we're going to mitigate the drainage. And then what really comes to be slightly the majority of time, I will talk about that more in a second, but the bulk of the time on paper is still this calibrated treatment design system. So that's, we've defined the runoff which will occur, we know where we want the facilities to be, but then we go back and forth and calibrate and iterate and find out what those need to look like to actually meet those requirements. Lastly, what I consider just a catch-all is often summed up just simply as reporting. Well, that's not just reporting, writing words in a document that you'll submit. Really, that is a catch-all for spillover of time and any one of those other categories. And also the explaining and demonstrating and communicating the design, something that if you've seen a previous webinar of mine, you'll note that I think that's a very, very important item to get right. So this is a typical, as we would bill it, project. Now, what I'll start showing here is, I think in the real world, how we might actually spend time on this. So I'd say maybe a little bit less than a day is maybe our preliminary plan, back of a napkin proposal. Then we get into, again, it doesn't take very long to delineate our runoff potential on the site, even laying out the treatment. Our initial guess, maybe our overly optimistic guess of how we can get away with treatment. But the vast majority of time, we're going to spend calibrating. So calibrating, iterating back and forth, using, again, in this typical workflow, these are spreadsheets, CAD files, in-house tools, or very simple programs. So let's say we have a project, and I've had this personally. I have 6 different tools I'm using and multiple different teams that I need to communicate to. That calibrating, getting the final design, I make an update, that goes to the site team. Oh, that's a little bit too late for them, right? They have to change their site plan. It comes back to me with a new constraint. That's where the vast majority of time is spent and really quite wasted. What we'll look at in the next webinar is I think that we want to get that, and I think we can get that final treatment design as close to zero as possible, as close to what we'll see in a second. I might use the term automated. So here's the workflow for XP drainage. We'll start with that pre-developed or kind of the initial look at the developed scenario, looking at the runoff, the water quality volume, pollutant wash-off potential. Again, I looked at, or I didn't mention pollutant wash-off being a concern directly in the traditional approach. That's because we're assuming this is just a volume we're treating. Right? If we can treat the volume where those pollutants are held, well, then we're also treating those pollutants. Again, that's not always the case, and that is certainly something that we could have several webinars discussing. But that's the assumption that we're making most of the time in most areas. We can begin to use some quick estimation tools, so we can quickly and robustly estimate flow controls which would be needed, storage capacity, so on and so forth. And then we'll find it's fairly simple and easy to string together our stormwater controls, treatment train, connect the hydraulics of the system together. And then we get into the comparing and modifying, look at the results, okay, compare our different, we'd call them phases, or just your different ideas of the design. Compare those, modify. Again, that last section is where we spend a lot of our time in that traditional workflow. And as I said, what if we could automate this? Right? I want this to be as easy, as clear to understand as possible. So that next webinar, we're going to spend a lot more time talking about that. So today, focusing just on the planning and creation portions of this project. So we'll start with maybe some basics, right? Importing the background information. See where we are in the world. Image, CAD, GIS, and a surface. If you have a surface, we can do something that is hugely impactful, hugely important. We'll deluge the site. We'll see what that looks like. So that can be used, this item, the deluge option, is useful to many people other than just a drainage engineer. This is planners, landscape architects, very early high-level assessments of a site. So we'll touch on that in a second. Design estimates, well, I'm actually going to save that for the next webinar where we do a lot more of the design and optimizing. So today we'll go and look at templates and how important those can be, how quick they'll be to set up, and how kind of robust it makes the system by setting up templates. And it's it's approachable and easy and quick to kind of do the following, right? Delineate your inflow areas, place your controls where you think they'll start out, and then connect your system together. So let's look at the software. So here we have XPDRAINAGE. If this is your first webinar, you haven't seen it before, or you're not already a user, you'll see if you've ever used a Windows computer, if you've ever used a common, let's say, a GIS CAD package software, this is going to be pretty easy to pick up, pretty intuitive. We have a ribbon across the top, and if you were to follow this ribbon, well, you would end up completing your project. All right, start with kind of plan, moving around, plan data, and bring in your site information, and work your way through building, analysis, and results. Okay, so the first thing that we're going to look at here today is bringing in that background information. So I'm going to interact with this tree view on the left. It's the way I prefer to do it. We could also navigate through this ribbon item here. Let's start with background image. Okay, that's the maybe easiest one. Again, right click and you can just select background image. Now I could make that a little more transparent. And we'll see here is our image of our site. Okay, well there clearly is a zone which is ripe to be developed. Looks like the rest of these other phases of development have already happened. This is what we'll be working on today. So here's our background image. Gives us a place to start. Next might be a CAD file. So if I right click and there's a CAD file that I could import. You'll see we have some tools, what I want to touch on here today to make this easier, right? So often CAD files, you don't want to have to save a file in a certain way just to be read by another program. So we can look at all the layers in this model, in this file. Well, I might only select a handful of the ones which I think are important. Different property boundaries. Let's say I have the fences here. I have my really first proposed system, roads, templates. So we'll see what this looks like here. So this was what I've talked about in previous webinars, maybe a bit backwards to already have the CAD laid out, right? So I have this layout, but if we had used the deluge, we might have laid this site out a little differently. So we'll see that in a second. But here's the kind of initial planning level guess at where we're going to be. So we could maybe just assume that this is going to be constructed, or again, this could be very early stages. So we have our image, we have our CAD file. We can bring in our surface. So the surface, right click. We have a range of formats and some really useful items that we can perform on a surface. So let's see the first one I happen to have this CSV file. And I can select this is going to be in US feet. Okay, great. Well, I can trim this surface. I can optimize, and that's something I think is very important to show. So this surface happens to already be fairly well trimmed down to our site. You can see this light green teal outline is the site that we're going to be working in. Often unless you've already trimmed something down in GIS, you might get a huge surface file. And there's really no reason for that. You have something which is thousands of square miles. Well, that's quite heavy on a computer to manipulate that information. So here's where we can trim this down. So I zoomed in, and let's just say, for grins, I might start here and trim down this portion on the right. I don't need this. Again, this is already pretty well trimmed up, probably something which was done. I'll just say this. This is the area we want. And so great, trim that. And in fact, I could even optimize this. So, I even strip out, duplicate points, have maximum points be about 100,000. Great, so it created the surface for me. It's that quick. So if I color fill, you can see what we're dealing with here. Now in the lower left corner of the screen, there's X, Y, and vertical Z value, or Z, depending on where you're tuning in from. So you can see I hover over, here are the elevations on my site. So that's something that I always encourage someone to use. Try perhaps optimizing a surface if it's quite heavy, okay, or trimming it down first and foremost. If you haven't already done that somewhere else, that's a very common task in any project using any software. Well, you can do it right here within our interface. It makes it pretty easy. There are a range of files which you could use for to create a surface. ASCII grid files. Land XML is a very popular one. So from Civil 3D, if you're bringing a surface over, we'll just export that as a land XML, and we'll bring that on into XPDRAINAGE. Okay. All right, so we have our image, our background information, the surface. Well, now the next thing would be to deluge. So it's as easy as right-click and go, and we've now just deluged our site. So let's take a look at what this does for us. I'll zoom in a bit. And we can see that this is giving me these vector arrows. I'll turn the background image off. See vector arrows. It shows me some depths of where all of this runoff will pond up. So this is such an easy thing to do. It's so important. So some of you might be familiar with what two-dimensional hydraulic modeling is. That's a very large, sophisticated thing. We have a slightly simplified version of that we're processing here. Again, if you're familiar with 2D models, sometimes they take hours to run. Well, this was clearly, half a second. So we apply this snapshot of a 2D assessment onto the site, and this is just going to give us an indication of, with these vector arrows, you can really delineate perhaps your inflow areas. All right, you can delineate your site. All right, delineate our inflow areas, or you'll see here the majority of volume on our site runs to this southern section, southwest, and ultimately down here into this marshy area. Well, that's ultimately a good place for a pond, probably, kind of a catch-all high volume system. So this is how we plan out our site. So in this case, if we were at the planning level, and we might say, well, we could get away with a lot of storage on these streets. You see that's what's planned out right here. We have these little returns for rain gardens. I might refer to them as kind of green streets. So green street bioretention systems can be here. So we have a lot of locations where we could place our green street systems throughout our site. Now there's also this large collection zone we need to bring in. We need to kind of route this flow down maybe to a pond for the really high volume treatment mitigation. So perhaps this would be a good location for a swale down one part of our site. Again, if I turn on the vectors, you can really see, all right, how this flow is going to move from this northeastern portion down across the site, graded so that the streets will capture the flow, and we can route that down here to the southernmost portion of our site. Okay. Now there are some areas where maybe we can't accommodate for one reason or another a rain garden. Maybe there's not enough relief on one of the areas. Maybe we need something other than a rain garden. Okay, a swale works here but not in this denser zone. Well, we have the ability to look at pervious pavement, underground storage. Okay, well, we could see that we could put in some pervious pavement maybe up here in the northeastmost section, maybe on these downhill cul-de-sac areas. We can use some pervious pavement to ensure we're getting treatment as close to the source as possible before we go into some sort of detention basin. Okay, so great. So now we have an idea. We've planned out the site a bit of how we're going to tackle this drainage. Next thing would be looking at the templates. So what do we have? So the templates are really all of the different building items in our model. So if I go to the building tab, you'll see really all these same items here for templates. So if I was to delineate the inflow areas on the site, well, you see I've already set up templates for that. So I happen to be having an area which I'm going to call maybe a developed, residential developed land use. I've defined a pervious curve number, and then now I have a percent imperviousness. Area is 0. An important part of the software is we are going to force us to link up what is drawn in the plan to what's being calculated. So our template, well, we don't need to define an area, because when we draw or import or create our inflow area, this will get updated for us automatically. So really it's kind of the rest of the input here. Maybe perhaps pollution. Again, not something we typically are going to look at when we look at that first flush, that runoff reduction assessment. But in this case, I already have set up in this area, total suspended solids, phosphorus, nitrogen, what those wash-off levels would be. Okay. So I have this for both developed and existing, right, land uses, areas. Now we have something called junctions, right? So I have a manhole, or what I call a simple junction, where maybe some channels join together. Very common would be manholes. I'm saying default, our manhole is going to be 8 feet deep, maybe more of just even a clean out. Great. So I have this set up by default. Since we have a surface, when we draw any of these junctions or stormwater controls or connections, they're going to automatically connect together based on our input here in the surface. So I'm saying depth, I've manually said this is 8 feet deep. Well, the invert, well, it's -8. The vertical information we'll look at will automatically be updated based on that surface where I draw this in the model. So it'll automatically sample that cover level, and 8 feet deep, this radio button shows what will be automatically updated for me. So at some elevation, 8 feet deep gives me this new invert level. Okay. And really important, this really makes the system quite robust, to look at all the different stormwater controls that we could assess, that we could use, and also all the customization that we can have. So very, very common, the rain garden or bioretention. So I have two right off the bat that I've already laid out. A typical bioretention perhaps for my area, or a green street bioretention system. Okay. All right, we'll see here that depending on how we draw, if I have this top area, bottom area, base area, you'll see when I draw these facilities, okay, these will be updated. Now I'm saying the vertical walls, there's 0 slope, right? So these little rain gardens, these green street systems are going to be little vertical walled catchments, well, or a treatment, but perhaps something like a swale, well, it has 1 to 4 slopes. We want to be able to mow this facility, right? So we'll see setting up a template with some of the default slopes or depths, again, back to the green street bioretention. 1.2 feet deep in this case, in this area, is kind of the maximum you can have of ponding depth. Okay. We can get into, obviously the defaults are excellent to have set up for filter layers. Right? So filter layers, You can choose to have an under drain or not. Again, a lot of customization we can have here. We'll see what inlets and outlets look like when we string together our system. But you can have, of course, a default inlet, a default outlet. I happen to have one here. So I have a default outlet is what this high flow bypassed weir. Okay. So set those up. Ultimately, we can also have defaults for the pollution removal, either a removal percentage or first order decay, depending on what you want to do. In our area, again, we aren't really looking at pollution tracking, though the software could clearly do it. So our different controls, we have bioretention, we have pond default, a dry pond, where there's specifically in the advanced tab, we'll set up some infiltration to occur, right? So pond can fill up, but it's kind of on an infiltration medium. Porous paving, so I have porous asphalt defined. We'll see this area kind of in this rectangle will be updated based on how it's drawn. And these other items I've already input. A void ratio in this pavement, I think 40% is pretty standard, give or take a few percentages. But so that's the void ratio in this. Okay. Swales. We also have infiltration trenches and a few others. But that's just to give you an idea of setting this up. You do this on one project, and really it's set up for life. You can transfer this template to any project, use this anywhere. So you spend just a few minutes, 5 minutes doing this once, and forever on, you can really automate the way you string together a model. Okay, well let's look at delineating those inflows. So the first thing we might do, again, looking at my deluge. All right, well this area, this is going to be a little park zone. This area really predominantly runs down to this corner here. So perhaps our first facility, our first treatment will be right down here in this corner. So I could go to the Build tab, and I could select one of these items. I'm going to say that residential developed. And if I snap, I can turn the snap button on. You'll see I could really following what I'm going to expect is going to be some curb work, which will kind of confine the flow. And really, I like to use these arrows showing the deluge. So I turn this off, the deluge. You'll see what I have just defined. Here is one inflow area. Okay. I could continue to delineate further. I could also import, just for the sake of time. I'll show another way to do this. So we could delineate our site, click around, that's 5 or 6 minutes to add those other catchments. Well, what if I was to right-click on inflows, and then I could load from GIS. So I have a shapefile of really the remaining catchments, which were already delineated. Pretty often, this might already exist on a project. Maybe there's a retrofit you're doing. Maybe this work is just already done. It's really easy to do in GIS for someone. Maybe there's a GIS technician. So that's why we accommodate this. You don't have to do everything in our interface. I think it's quite easy. But great, you have someone that did this in either CAD or GIS. We can now import that. You'll see this all imported with the same, that urban residential land use. So I have 1.3 acres. I happen to be using the SCS method on this in this model. And this area will be updated based on how we have drawn or imported those polygons. So pretty straightforward. So we want to create some sort of treatment for this catchment. All right, well, let's go to the controls, and I could select one of these. I might say, even though it's going to be kind of within this park, we could still use that Green Street bioretention. So Green Street bioretention, and maybe I'll just freeform draw as a starting point this facility. So what did I just do? I just created, as you'll see, this facility here. So we have this ponding zone up top, filters underneath. You can choose to have an under drain. Okay, but that's, here's some real world examples of what a rain garden looks like. Okay, get some ideas. All right, so now what happens? So our exceedance level, right, this was all set based on how we placed this in our model against our surface. So the top level was sampled from our surface 1.2 feet down, gave us our base ponding level. Here's our area. And one thing we'll look at a lot more in the next webinar, but again, we're just starting out with kind of a guess of where I want this facility to go. That's all we're doing at this point, is I'm saying this inflow area I want to be treated by, right, this facility. We don't really need to do anything more than that at this time, okay? But if we were to say, you know, it's 680 square feet, maybe I think this needs to be a little bigger. Well, you could enter, let's say, right, 800 square feet. And if I apply, you'll see what's being calculated will always be updated in the plan and vice versa. Right? So there's never that disconnect. That's really the first breakdown of communication, is having any sort of disconnect between what we have in our plan view, right, what we could share to others. You can export this, we'll look at later. So we need not allow a disconnect to occur. So that's great. Again, filter layers, all the template information is here. Okay, well, what if I was to connect, so I could just right click, I could connect this inflow. I want this to go to a facility right here. So here is my facility. If I select that grate icon, well, that is the inlet of my facility. So why is that important? Well, we're going to say that you could have an inlet grate on a street, right, that would restrict the flow getting into, let's say, a manhole. We can look at that in a second. So we have that manhole, which could have restriction. In our case, since we have all of the flow from this inflow area, you know, it's not really a point source. It's not flowing into one point. It all is flowing kind of along the edges of our facility. We can have a lateral inflow. Maybe a subtle difference, but it really will affect, right, how the inflow hydrology arrives at this facility, and then also how the hydraulics can leave this facility. So by allowing for a lateral inflow, we're going to allow really a different shape of hydrologic routing to that facility. Just for clarity, I'll turn off the visibility of those inflows. And let's just look at, we have this one facility here, and I know that there's going to be a manhole in the street where this will drain to. Okay, well, I could add in a typical manhole. In this case, just place it right there. Sure enough, right here is my cover level. Got updated, 8 feet deep. Okay, easy enough, just like we looked at from that template. And it's just a matter of, right click, and we can add in a connection. I have a default, let's just say a 12-inch pipe. Now, what is this? So I happen to be seeing this radial display. So there's already an inlet here. I could connect to this inlet. So we'll see what that looks like now. So go to inlets, and I'll see that I happen to have, right, an inlet, no restriction. Again, I could have, if I had flow from a catchment, let's say I have this inflow here. If I have this inflow, this whole area might drain into this manhole. Well, I could once again, I'm going to connect this into a new inlet. So now I have this inlet here. I could restrict that flow. So this is overland flow on the street. It's going to go through a grate. I could apply high, low bypass, a percentage restriction of flow. And then I could also specify there's maybe a pipe underground that leaves this manhole. There's also maybe an overland flow path. So all those items which in that traditional workflow using 8 different spreadsheets or tools, there's just no way that I could assess this. This really exists in the real world. We have to look at it, right? So pretty quickly we could see that we could add in, we could draw our facilities. Just to show that we can, I'll import. I happen to have some of these Green Street bioretention systems that were already delineated through another tool. So I'll right click on the stormwater controls and I could add in from GIS. So controls, great. And you see I can select what template to use, so it is automatically going to be set. So any of these items which were just imported, based on how they were drawn, that polygon, it gives me the elevation relative to that surface, right? The top area, okay, the volume that it's going to be able to store. You can see the volume is down here in the lower right, and all these filters, or sorry, all of these tabs are already filled out for us. So hugely important, really quick and easy. Now there are a few other items perhaps to show. Right? We have bioretention, we've seen that, and we could look at how these facilities, of course, could connect into our, I could select one of the two inlets. This first inlet was that free, no restriction. Okay, we could string together our system. Now I could also have perhaps a swale, the swale along the perimeter of our site. Again, I happen to have this in a CAD file. And you know what? I'm only going to bring in the swale right now. And sure enough, I can select typical swale from this. All right, same idea. All of this information is automatically updated for us based on the surface. We can adjust this. The surface makes for a good starting point. We can adjust the levels, adjust the widths, all that information. And again, our pond, which we could either manually draw or again just import from this CAD file, where it's already been kind of outlined where we think it's going to start. Again, we'll talk about this more in the next webinar, but all we really need to do at this point, it's like this dry pond, is place where we think the treatment needs to be. Because we have some tools, some tricks, some ways we've made it easier to optimize and attenuate, or optimize and calibrate the system. Okay. So if I turn back on the inflow, something we'll find in a lot of cases, if you were to draw a control, the inflow area will automatically be attached to that item. So we draw a new stormwater control, we'll find that inflow will automatically know that, well, if you've drawn it here, it will drain to that point. So something else we didn't really see yet would be this porous asphalt. I mentioned this upstream, uphill area, I should say. And for its worth, we might want to, right, so I select that asphalt, and we can say that is what is going to be defined up here. So based on how we drew it, the elevations, okay, we get that area, we've already input this void ratio, what have you. So that's as hard as it is. We could add in manholes to allow for collection. So I could say I just want a typical manhole. And I know there's going to be kind of collection at the various intersections. Okay, right? So I applied a manhole here, and you see it snapped that this area drains to this. Well, we could change those. That's all there is to it. So all we would do now is just right click, and we could connect our facility. I happen to have this 12-inch PVC pipe we might start out using here, and we could connect our facility as we work our way downstream. So just to show kind of that drainage system, maybe I'll add in a couple more manholes. We could show this would drain. Now again, this may That actually snapped the wrong thing here. I'll just delete this one. So you say this could drain into that swale. So we might have a daylight pipe pops out into that swale. And I will say perhaps this goes between some property and connects. Daylight's right out there. So as we're building, again, this is great, this is fine, but I want to maybe see the verticalness of this. I want to see a profile. So I can add a profile, and I could go from here to here. I could see our first pass. You'll see our pipes were automatically connected to the base of those manholes. Okay, makes that really easy when you use, again, I use that term, string them together. We add these together, automatically attached to the base, attached to the outlet. You know what, hey, this is a little deeper than it should be because we place that in the middle of the area. Didn't really pick up the elevations right. Well, I could manually go and change these. I could manually go and change these profiles. Okay, again, I could update the profiles, update our facilities themselves by double-clicking on that profile. So that's the way we're going to start this project. Again, this just a few minutes, and we have not only planned out the whole project, brought in all of our background information, but very quickly and easily either import or really almost the same amount of time to just delineate inflow areas, our different stormwater controls, connections, to find all that in the software. Okay. The real important item here is how useful and how robust the use of templates can make everything else we do. So we have templates that are even at all a good starting point. It's going to make the rest of our work that much faster and easier. So what we'll look at next time is we're going to look at, well, we just have plopped down our controls, and we've just kind of plopped in, I said, a 12-inch pipe. Is that even correct? We're going to look at ways to maybe automatically size the pipes, automatically size these controls, okay, and to really process the hardest part, the most laborious part of this work into as concise a piece as possible. Okay. So once again, thank you for joining today. My pleasure to talk about this product and what I do. So if you have a question, certainly contact us at amsales@xpsolutions.com. Thank you very much.